Hi everybody, this video is going to review the properties of exponents, which you have seen before, most likely in 8th grade. And your blue book, which is new, actually cut out this chapter, which the old Algebra 2 book did cover. And I think it's important to spend a couple days on it because properties of exponents are something you haven't practiced in possibly 1.5 years now. And they're something that you need to know 100% confidently for your future math classes. So here's your video reviewing the rules, and we're going to be working our way up to more and more complex expressions where we'll be simplifying them. So for this video, we are going to be doing properties of integer exponents, and that just means everything that we do in this video and when you come back for the first day will be whole numbers. Then what we're going to do is we're going to review, or maybe for some of you, learn for the first time rational exponents. That would be like x to the 1/3. Or 27 to the 1/3. What does it mean to raise something to a rational, which means a fraction, exponent? After that, we will talk about properties of radicals. Now, most of you have seen everyone has seen a square root by now. We're going to work with cube roots, 7th roots, etc., and simplifying them and solving equations with them. So this is kind of a little unit on all of these three here. So let's go to the 5 main properties of exponents. When we do exponents, the things you need to remember is if I have a to the n, a is going to be called the base, n is going to be called obviously the exponent or the power of a. And two things that you're going to need to keep in mind here. These aren't really the 5 main properties, but they're things that you always need to know. Is that if I have something to the 0 power, no matter what it is, whether this is a number or a letter, it's going to be 1. And the next thing is if I have something to a negative exponent, in order to make the exponent positive, because in rational expressions, we don't want a negative in our final answer. It's not considered to be proper. We don't want negativity. We want all positives. So to make it positive, you kick the base and the power into the denominator. Now, you can also have something like this. You could have like 1 over a to the negative n. Well, if it's already in the bottom and you don't want any negatives, then you just move it to the other spot of the fraction, basically. That's how you can think of this. So these are 3 things that you're going to want to keep in mind. And remember, no negative exponents in final answer. That will apply to all the problems that we're doing. So here are your 5 main properties. Now keep in mind whenever we do it, the bases need to be the same. So if I'm trying to combine 2 things, if their bases aren't the same, you can't even combine them. They're separate expressions. It's kind of like when you need like terms. If the bases are the same, you can apply these 3 here. Your first property, and we're going to go through these pretty quick because again, you've seen these before. It's just at this point a matter of brushing up on them. If I have a to the 3rd times a to the 5th, sometimes people forget the rule, like, oh, do I add the exponents? Do I multiply the exponents? Just think a cubed means 3a's, a to the 5th means 5a's. You write it all out, which you never should do normally, but just, again, this is like a little demonstration of why it is what it is. You add your exponents because really you're going to end up with 8a's here. Now, this rule is called a product of powers. Product means you multiply 2 powers. You do not necessarily need to have the rules memorized, but you should be familiar with them. So if I have a to the m times a to the n, it's a to the m plus n. That's how you simplify it. Rule number 2, if I have a to the 3rd to the 5th, what that really means is I have a cubed, which is a times a times a, 5 times all multiplied, and you're going to end up with 15a's. And the way you get that without doing this all out is by multiplying your exponents. So this is called a power of a power, and hopefully that name makes sense because I have a power of a power. So what I do there is I multiply my 2 powers, just like here, 3 times 5 is 15. Number 3, what if I have 2 different bases to 1 exponent? What that just means is I'm going to have a times b multiplied by itself 3 times. And in that case, as you can see, I end up with 3a's and 3b's. So anytime you have things in parentheses, what you're going to do is every single term in that parentheses gets the power. So a times b to the m, a gets the power and b gets the power, and they are multiplied just like these or multiplied. So let's include some division problems here. What if I have a over b to the third power? So I still am considering two different bases here. If I'm dividing a and b this time and they are to a power, if you write it all out here, as you can see, you're going to end up with a to the third power and b to the third power. So instead of writing all this out, what you could do instead is just give each term in the parentheses the power. Just like you did here when they were multiplied, same deal when they're divided. This is called a power of a quotient. So if I have a over b to the m, it is a to the m over b to the m. Last rule, rule number 5, if I have the same base again, meaning I can combine these two here, and it's, let's say a to the 5th over a to the 3rd. Since the bases are the same, I can cancel here. I end up with just 2 a's, and a quicker way to do this, instead of writing it out, is just to subtract your exponents. This is a quotient, meaning division, of powers. So the rule for quotient of power says if I have a to the m over a to the n, you're simply going to subtract a to the m over n. Sorry, a to the m minus n. What I want to do now is work my way through a set of example problems with you. I will do them out with you and explain generally how you want to approach them, and then I have some problems for you to do afterwards. All right, so let's try a relatively simple one, and we'll work our way up as always. Here, notice we have only multiplication. Now, you do not want to apply properties of exponents to regular coefficients. People get in the habit of saying, oh, x to the 5th, x to the 4th, x to the 0, let's add our exponents, so that would be x to the 9th, and then they want to add 6 and 3 and get 9 here, which is just not true because 6 times 3 is 18. So you still do your normal number rules for the coefficients, obviously. It just applies to the exponents. X to the 0 is 1, multiplied by 1 is nothing, so that's why that was completely irrelevant. Let's try one like this. Negative 3x squared y cubed to the 3rd times 2xy. So I'm going to start here, and there's always different ways to approach this, but generally you want to start inside the parentheses here. I have negative 3 to the 3rd power. That would be negative 27. I have x squared to the 3rd power. Well, x squared to the 3rd power, you multiply, so that'd be x to the 6th. Then I have y cubed to the 3rd power. That'd be y to the 9th. And I'm still multiplying by 2xy. So now this looks just like this problem here. Keep in mind these problems are meant to be done without a calculator. So negative 27 times 2, that'd be negative 54. I'm going to add my exponents here. So there's a 6 here for x and a 1 here for x. That'd be x to the 7th. I cannot add the blues and the greens because the bases are not the same. So I'm going to do y to the 9th times y to the 1st. I add them, I'd get y to the 10th. So these ones aren't too bad. Let's try one more entry-level problem. Throw some division in here. All right, so here I have p's and I have t's. You can only combine the bases that are the same. So if you divide, remember you subtract your exponents. So p to the 5th over p to the 1st, you're going to subtract 5 and 1 and get p to the 4th. Here I have 2 minus negative 4. That'd be 6. So I'm going to get t to the 6th there. This problem here, I have 3 different things, 1, 2, 3, all raised to the 2nd power, meaning they're each going to be squared separately. If you wanted, you could rewrite this first like so. Doesn't matter because in the end, you're going to get rid of that negative exponent anyway. What I would probably naturally do is say, all right, 3 squared is 9. X to the negative 4th squared, I'm going to multiply as x to the negative 8th. And y cubed squared, remember that's just y cubed to the 2nd. You multiply, you get y to the 6th. So that'd be 9 over x to the 8th, y to the 6th, which you would get here also. It's just you moved the x first. So that's one way you can see. There's 2 ways to approach it. The next example, you'll see even more clearly how you can do these 2 different ways. Let's say I have parentheses in a parentheses, x cubed, y squared to the negative 2nd, all over x squared, y to the 4th. Keeping in mind that I do not want negative exponents in the end. There's 2 ways to approach this. You could say, let's get rid of this negative right now, and you could rewrite this Now you have to be careful when you rewrite it because this means that the whole thing has to go in the bottom, like x cubed y squared. This completely goes in the bottom, and its exponent becomes positive, and then the x squared y to the 4th, which were there to begin with, are still there. Now, what I would do is work my way from the inside out. So let's take care of this set of parentheses first. So I have 1 over x cubed squared, you multiply. That'd be x to the 6th. Y squared squared would be y to the 4th. And these two are still here waiting their turn. And now you're ready to use them. So you're going to combine your x's and you're going to combine your y's. All the powers are positive, so you don't have to do anything anymore. So now you add. So that'd be x to the 8th and y to the 8th once you've added. You could also say, I don't want to move anything first, and you could say, all right, x cubed to the negative 2nd is x to the negative 6th. Y squared to the negative 2nd is y to the negative 4th. These two are still here. And then you could say, okay, if I'm dividing, you're going to subtract. So then you could say x to the negative 6 over x squared. Negative 6 minus 2 is negative 8. And then negative 4 minus 4 is negative 8. But we don't want negatives in our final answer, so they would each have to go into the denominator. Notice I'm creating a fraction. Now, it wasn't really there in this step, but it has to be there to make our exponents positive. So that's what I mean when I say there's more than one way. Sometimes there's 3 or 4 ways to do these. So whenever you practice these, you might notice you're not doing them the same way as your group, and that's okay. Let's try another example here where I have one large expression all raised to the 3rd power. I'm going to try 2 different approaches. You can start on the inside first, or you can start with the outer power first. I'll tell you at the end which one I generally do and why. Let's start on the inside here. Actually, no, let's start on the outside power first. So we're going to apply this cubed to here, 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 and here. Each of these 5 terms gets a power. Again, notice I have 1, 2, 3, 4, 5. But wait, I actually have more than 5 bases because this negative here, I'm going to treat the negative as a negative 1, and then an m to the 9th, and then an n cubed. So I actually have 6 bases, and each of my 6 bases will be cubed. So negative 1 cubed is still negative 1. I'm going to keep the negative there. Those negative signs are very important that you take care of them carefully. M to the 9th cubed, so I'm going to multiply. That'd be m to the 27th. N cubed cubed is n to the 9th. Going in the denominator, 5 cubed is 125. M to the 7th cubed, so that'd be m to the 21st, and then n to the 8th cubed multiplying again, I get this. Last step that I'm going to do here is subtract. So I have m to the 27th over m to the 21st. We're going to subtract and get m to the 6th. N to the 9th over n to the 24th, we're going to subtract. We're going to get negative 15. The negative and the 125 are still. Make sure you're very careful about what belongs where in terms of numerator and denominator. N to the 15th, I'm going to bring to the bottom to make it positive. What you can do instead is you can start on the inside. So negative and 5 are still there. M to the 9th over m to the 7th is m to the 2nd. N cubed over n to the 8th, that would be n to the negative 5, but I'm going to preemptively put it down here to make the exponent positive. You can start doing that to make your life easier here. And that would be cubed. And then what you do is cube each of these 5. So negative 1 cubed is negative 1, m squared cubed is n to the 6th, 5 cubed is 125, n to the 5th cube is n to the 15th, which is the same thing we got here. I'm going to recommend you start on the inside, but you certainly don't have to. It is your problem. As long as you're going to get it right, you can start however you want. But if I'm going to do it out, I will usually start on the inside to have smaller numbers. So now it's your turn to practice. Here are some problems that I want you to do. Here are the numbers you're going to do. So can you pause the video on here? You're doing 5 to 14. 27 to 35, so pause as needed here and here. And then you're going to do these problems here. Make sure you show all your work out, no calculator, and I'll see you Monday.